Hello everyone, in this video I'll be talking about factory design pattern. So first we will understand what is factory design pattern, then we will write code in Java and see how it works. Okay, to understand what is factory design pattern, let's consider one example. Let's say we have developed one application, logistic management application. And in the first version of the application, we are only supporting transportation by trucks. Okay, after some time, let's say our application become popular and we also got a request to support the sea logistics. So here comes a challenge because as of now in the first version of the application, all our code is coupled into truck class. And to add the ship class, we have to rewrite the entire code base. And let's say after some time we got a request to support the air logistics also. And some things keep coming up. And every time we have to rewrite the entire code base to support that feature. So which is pretty nasty, and also it will make our code pretty nasty and with lot of conditions to change the behavior of the code as the situation, right? And this is a kind of a problem because we can't just keep rewriting our code again and again with all the conditions and all. Like we need a solid structure. So to solve such kind of problem, we use the factory design pattern. So what factory design pattern suggests is, it says instead of directly creating the objects of truck or ship, we will create one factory method. And the job of this factory method is to create the object for us and give us. So you might be thinking, right, we just replace the constructor call and how it will solve our problem. And to do this, here comes the interface in picture. What this interface do is all the classes, all the let's our entities, truck or ship, will implement this interface. Let's say in our case, we will name it as transport. So this transport interface will be implemented by all the logistic services, which are truck or ship. And all the methods are defined in this transport interface, are declared in this transport interface and can have their own definition by their own entities. Let's say truck can have their own definition of delivery method and ship can have their own definition of delivery method, right? And the return type of this factory method is also the transport. So when we ask this factory method to give me the object of truck, so the return type we will receive it as the transport, and in the transport we can directly make a call to delivery method, right? So we I know it might be pretty confusing what I'm saying to understand. So let's just write the code and see how it works. So let's write the code for factory design pattern. I have created this project in IntelliJ design patterns, and in this now we will write and create this package factory pattern, and in this we will write the code for our factory pattern to understand how it works. And this is our the abstract factory which we will be covering in the next video. So stay tuned. So to understand the factory pattern, how it works, we discussed about the interface. So first let's create that uh, interface, and it will be a transport, right? As we have discussed. So I've also initialized the git, as you can see, so that's why it is asking to add the file, which is okay. And here we will declare one method, deliver. Let's say it will return type is void, right? So now we will create our two entities. First is truck and second is ship. So let's create two classes. First is truck. So each class will implement the transport interface. So you will see how things work. Just bear with me, just stay with me for now. This will implement our transport. Okay, what the and okay, yeah, it is asking us to override the method, delivery method. Let's say here we just simply say s out delivery is done by truck. Okay, so now let's create one more class which is our ship for ship logistic, as our requirements come to support the ship classes. Okay, so now this will also implement the transport. So here also again we will override the method deliver public void deliver. This will also simply do s out delivery ei delivery is done by ship. Okay, So now we have created the entities and the interface. So which is, and both the entities have implemented this interface transport, and we have override the method. Okay. So now we have discussed about the that logistic factory. Let's just create one more class which will be our logistics factory, and in this we will define one factory method, so which will be our public, and this here is the trigger, like the key part of this factory design button. This will return us the transport, and it will be a factory. So now here we will create the object either of truck or the ship, or what we can do is we can create two more classes. Let's say road logistics. Let's say why I'm saying road logistics, why I'm creating these extra classes, road logistics. Let's say today you are only transporting using trucks, but after some time you also got a request to transport using mini trucks or different type of transportation facilities by road, or different type of ships, like something similar to that. So we can create one road logistic class, and this class will implement extends the logistic factory. Extends our logistic factory. So here also we will override the factory method, and this road logistic. Now we know that truck is the part of road logistics. So here this factory method will return us the object of truck. Similarly, we can create one C logistic class, C logistics. This will also extend our logistic factory, and here also we will override the our factory method. Okay, so public transport and factory. This will return us the ship object, because ship is the part of C logistics, which is clear, right? So what we, let's say, so tomorrow you have, right, something different type of shapes or different type of road facilities, different type of trucks. So you can like maybe accept one enum here, and according to that you can create the object of shape or different type of shape. Similarly, we can do in the truck class. For now, we will just do it in the fact this logistic factory, which is the class with, and with this class our client will interact. So because here we need to know that which object to create. We know that the return type is transport. The object, whatever we are creating, it should be of transport type. But we need to know that the transport should be of sea logistic or it will be of road logistics. So for that, we will create one enum to get to know what we need. So this will be logistics, and we will call it what we will call it. No, nothing. It just either it is road or either it is sea for now, because we have only road and sea logistics. And this logistics will ex take one parameter logistic, and if I don't logistics, sorry, if this logistic the type logistics equal logistic dot road, we will say return new the road factory. We call the road factory object uh, road logistics or load logistic, and this here we will say the factory. So what will happen is now we will this road logistics, this factory method inside the road logistics which we have override, this will return the truck object. And if we have, like say have different type of trucks or different type of facilities, we accept one another enum here, then create another object accordingly, like we are doing here. I don't know what is this problem, we will figure it out. Else if logistics equal logistics dot c, we will create the object of C logistics and ask to return the factory. What is the issue? Let's see what is. We will figure it out. What is the issue here? Let's see this. Method does not have override from its superclass. Okay. Okay, yeah, we are not actually overriding it. So we can remove this. Yeah, we are only overriding in here in the entities. So this is solved. Why? What is the okay? And instead of if we can also return one, default transport. So right now we have nothing. So in that case, we can just simply return null, but we have to, take care of this null pointer exception. Uh, but for now, we can just skip it. So we have this logistic. So now let's create our main class. Okay, this logistic is not added yet. We will add it later. So this will be our logistics app, or you can say main class of the or this is the our client which will interact with the backend logistics app. We can call it. Let's just add this one, and we can here create a main method. And in the main method, all we need to do is just to create the object of this factory class. Now the logistic factory equal logistic factory equal to new logistic factory, and now this logistic factory will give us the sorry give us the transport. Let's say now I want to deliver my stuff using truck. So what I will say, I will ask him to give me the road logistics, and in the road logistics we know it for now it will only return the trucks because as of now we are only supporting one trucks. So we can say transport equals to truck, right? Now if I say truck dot deliver, that's it, our job is done. So if I'll just run this, it will be clear. It will build this. Okay, and delivery is done by truck. Now let's say now I want to use the C. All I will change here is this input only, and now everything will remain same. And if I run it again, as you can see, delivery is done by ship, right? So this is how factory design pattern works. And one more thing, let's say this is the client side, and side doesn't need to know like how the object creation is happening in the back end and everything. This just need to create. Okay, I want the C transport. Give me the C transport. This will become C. This will become ship. If we are sending C here, right? And everything is already handled. So the thing which we have discussed, let's say now we got one requirement to support the air logistics also. So let's just see now what we need to just simply add a very small change and everything will happen automatically, right? So let's say we just add one more class to support the air logistics. We will say air logistics. Add this. In the air logistic, we will use airplanes. So this airplanes will implement our transport, and here we will override the delivery method, which is public void delivery, which will just say s out. Okay, something is wrong. What is wrong? No. Delivery is done by airplane. Airplane implements transport. Okay, something is wrong. Just give me a minute. What is some? This is similar. Oh, sorry. Oh, deliver. Okay, it is not delivery. It is deliver. Sorry. Yeah. Just remove this. Okay. So our airplanes are ready. Now in the air logistic, we will create it. This will extend our uh, logistic factory. And in the logistic factory, we will define the factory method, which will return the transport, and it will return the object of airplanes, right? And so all the changes we just did to add the airplanes, just we added one this air logistics class, we added one airplanes. If we want to add different type of airplanes, we can add it here, or maybe helicopter or something in the air logistics. So we just need to add classes which will implement interface, or the entities will implement the interface, and the classes which are like the air logistics or road logistics, this will implement a main logistic factory class. And inside the logistic factory, we will just, yeah, and in the logistics, now we all have road, sea, we are also supporting air. So we will just make a change in our enum. Then we just need to change this factory method, else we will do this. Else if logistics equal logistics dot air, give me air logistics dot factory, and this will be like this. So okay, I have initialized git in this my project. So all this code you can find on the GitHub. I will put the link in the description box below. So if you need any help, you can just comment down below, or like look at the code on the GitHub. You will find the link in the description box. So I guess all the change is done. Now in my main class, which is logistic app, let's say now if I want to do the delivery by airplanes, I will simply say air, and the job is already handled, right? So this input you might be like in the actual application, this input you can take from the user side. Okay, right, that okay, you want to deliver your product by ship or by truck or by air, so like from the APIs. So this is how you can handle the scalability of your code. When some requirements come up, your code just don't break up. It will be flexible enough to add more features, to add more components. So this is how factory pattern will help us. So the main thing which factory pattern suggests is just the client do not need to know how the object creation is happening. We can just say airplane here, right? All the client needs to do is just to ask the factory, send me the air, send me the shape, or send me the truck object, and everything is handled in the factory class. The object creation, everything is handled. And if we need to add other components, other features, our now the structure, the design of the software is like that. We can easily just add that class, and the existing code is not affected by adding the additional features into our application. So this is how design patterns help us. So this is the first video in our series, factory design pattern. In the next video, we will be seeing the abstract factory design pattern, which will be more interesting. So please stay tuned. So if you have learned something, please like, share, and subscribe to my channel. Thank you. Thanks for watching.